Welcome to our module on business forecasting and predictive analytics, where we integrate GIS for enhanced insights. We will explore how leveraging spatial data can provide crucial future insights for your business operations. Today, we will dive into predictive analytics for business forecasting, a crucial area for future-proofing your business strategies. This involves using historical data effectively to anticipate future trends and make informed decisions. First, let us consider the foundation of predictive analytics, which is historical data. This data helps us identify important past trends in sales and understand customer behavior patterns. Indeed, these insights form the essential foundation for making accurate and reliable future business projections. Next, we have geospatial forecasting, which adds a powerful location dimension to our predictions. This method specifically incorporates various location-based variables like demographics or competitor proximity into the analysis. By doing so, geospatial forecasting significantly adds spatial awareness and context to our overall predictions. Finally, we come to predictive modeling, where we build the actual forecasting mechanisms. This stage involves using advanced statistical techniques and various machine learning algorithms to process the data. Ultimately, predictive modeling enables us to project future business outcomes and anticipate market changes effectively. Now, let us examine the critical role that GIS plays in enhancing predictive modeling capabilities. It primarily involves integrating spatial data to gain valuable location-based insights for smarter decisions. One key role is spatial data visualization, which helps us understand geographic distributions. This means mapping historical sales data to clearly identify specific regional patterns and variations. GIS also plays a vital role in demand forecasting, helping us anticipate future needs. We can predict demand effectively by analyzing various location-specific factors and their influences. Furthermore, GIS assists in thorough market trend analysis, revealing broader shifts. This helps us understand how geographic and demographic shifts impact overall business performance. Finally, GIS is crucial for effective risk assessment, identifying potential problem areas. It helps pinpoint high-risk areas for business operations, allowing for proactive strategic planning. Now, let us discuss the key metrics essential for business forecasting when using GIS. These are the essential data points needed for building robust spatial predictive models. First, we track sales trends, which are crucial for understanding business performance. This involves carefully tracking past sales performance across different time periods and locations. It also helps us identify important seasonality patterns in sales data for better planning. Next, we look at customer demand, estimating what customers will need in the future. This metric focuses on estimating future customer needs based on their past behavior and preferences. Understanding this allows us to develop more effective and targeted marketing strategies. Competitor influence is another vital metric, analyzing how rivals impact your business. This involves understanding the impact of competitor locations and their activities on your operations. We also analyze competitor market share to gauge their presence and strategic positioning. Lastly, economic indicators provide broader context for market conditions and opportunities. This includes analyzing population data and other economic factors to predict market changes. By assessing these, we can identify and evaluate future business opportunities with greater confidence. Let us explore various methods for predictive modeling that effectively use GIS. These are the techniques we use for forecasting business trends by incorporating spatial data. First, time series forecasting analyzes data collected over successive points in time. This method analyzes historical data over time to identify and predict future business trends. GIS helps map past sales data, applying time series models to predict growth patterns spatially. Next, regression analysis helps identify relationships between different variables for prediction. This technique identifies relationships between variables such as sales and demographics to make predictions. GIS incorporates factors like population density and income to enhance regression model accuracy. Spatial interpolation is another method, estimating unknown geographic values from known points. This technique estimates unknown values in geographic spaces using surrounding known data points. GIS can effectively predict demand in unserved areas by analyzing trends from nearby locations. Finally, machine learning for spatial forecasting uses advanced algorithms to find patterns. It uses AI algorithms to find complex patterns within large spatial datasets for better predictions. GIS integrates powerful neural networks and other machine learning techniques to enhance forecasting accuracy. We will now discuss identifying various growth opportunities through GIS-based forecasting. This involves uncovering significant future potential by utilizing powerful spatial analytics. One area is identifying emerging market trends, which helps anticipate shifts. This allows us to predict shifts in consumer preferences based on comprehensive spatial data analysis. Another opportunity is new store location potential, crucial for strategic expansion. We can identify high potential areas for business expansion by analyzing various geographic factors. Operational optimization also benefits, as we can refine our logistical processes. This involves adjusting logistics and inventory levels based on accurate, location-specific demand predictions. Finally, competitor risk assessment helps us stay ahead in the market. We can anticipate competitive movements proactively, allowing us to adapt business strategies effectively. Let us look at a retail expansion case study to see these concepts in action. The initial step in any expansion project is always thorough data collection. Following that, accurate sales forecasting is performed to project future demand. Analyzing demographics and the economy provides crucial context for market conditions. Competitor analysis helps understand the market landscape and potential rival impacts. Site selection modeling then uses these insights to evaluate optimal locations. Ultimately, the process leads to the identification and selection of optimal locations for new stores. We are now exploring the key characteristics that define spatial big data. It is important to understand the fundamental nature of these large, location-based datasets. First, we have volume, which refers to the sheer amount of data. This immense data quantity comes from sources like GPS, social media, and IoT devices. Next is variety, indicating the diverse types of data involved. This includes diverse types such as points, polygons, rasters, and even textual information. Velocity refers to the speed at which this data is generated. It is the speed at which spatial data is generated and must be processed quickly. Veracity highlights the importance of data accuracy and reliability. This characteristic focuses on data accuracy and reliability, crucial for making sound business decisions. Finally, value refers to the business insights we can extract. This represents the significant business insights extracted from analyzing large-scale spatial data. Let us now discuss the different types of machine learning used in business. GIS. These algorithms are powerful tools for uncovering hidden patterns within spatial data. First, we have supervised learning, which uses labeled data for training. This method trains models on labeled data, where inputs are mapped to known outcomes. It is commonly used for tasks like classification and regression in business context. For example, it can predict sales based on customer demographics and geographic factors. Next is unsupervised learning, which finds patterns without pre-labeled outcomes. This approach identifies patterns within data without relying on any pre-labeled outcomes. It is useful for clustering customers into distinct segments based on their behavior. This method also helps detect anomalies and uncover subtle spatial trends in your data. Lastly, reinforcement learning involves learning from an environment through trial and error. This type of learning allows systems to learn from their environment through repeated trial and error. It is often applied to optimize complex supply chain logistics for greater efficiency. Reinforcement learning also helps manage inventory levels and optimize delivery routing effectively. Let us explore various applications of spatial big data and machine learning in business. These applications focus on optimizing operations and enhancing overall customer experiences. First, customer segmentation and targeting help us understand our audience better. This involves analyzing customer locations and demographics to identify distinct groups. From these segments, businesses can create highly tailored marketing strategies and campaigns. Location optimization and site selection are crucial for physical business presence. This provides valuable insights for selecting optimal new store or warehouse placement. It analyzes competitor presence, population density, and traffic factors for best results. Demand forecasting and inventory management ensure product availability and efficiency. This predicts demand based on sales history, weather, and other local variables effectively. It also optimizes inventory levels and streamlines supply chains to meet market needs. Predictive maintenance helps prevent equipment failures and operational disruptions. This uses sensor and spatial data to predict equipment failures before they occur. It helps optimize maintenance schedules for various assets across different geographic locations. Fraud detection and risk assessment protect businesses from financial losses. This identifies fraudulent activities by analyzing unusual spatial patterns in transactions. It helps mitigate risks and prevent potential financial losses through proactive measures. We will now look at specific AI techniques used for market demand prediction. These advanced algorithms are crucial for achieving highly accurate demand forecasting. First, regression models are fundamental for establishing relationships between variables. This technique establishes relationships between market demand and various independent variables. Next, decision trees and random forests split data to classify demand effectively. They split data into subsets, classify demand, and handle non-linear relationships efficiently. Neural networks and deep learning models are excellent for complex patterns. These advanced models excel at detecting intricate and complex patterns in large datasets. Lastly, clustering and classification algorithms segment customers for better prediction. They segment customers into groups, predicting demand for specific market groups and segments. Now, let us move to a hands-on session. Developing a predictive model for business growth. This is a step-by-step guide to integrating GIS and AI techniques for powerful insights. Our first major task involves thorough data preparation for model building. Within data preparation, our first step is to collect and pre-process all necessary data. We gather historical sales, demographic information, and relevant economic indicators. Then, we clean missing values and normalize features to ensure data consistency and quality. We also geocode all location data, converting addresses into precise geographic coordinates. The next major step is to integrate both spatial and non-spatial datasets seamlessly. This means importing spatial data into GIS and non-spatial data into Python for analysis. We visualize spatial data on maps and create buffer zones around key locations for context. Finally, we merge these distinct datasets to achieve a comprehensive and holistic view. Our second major task involves actually building the predictive model itself. This begins with exploratory data analysis, which helps us understand our data. We examine the data deeply using various visualizations to uncover initial insights and patterns. We also create new, impactful features, such as the distance to the nearest store. Next, we move to model selection and the crucial training phase. Here, we choose an appropriate algorithm, like regression, random forest, or neural networks. We then split our prepared data into distinct training and testing sets. We train the chosen model using both spatial and non-spatial features for comprehensive learning. After training, we proceed to the model evaluation phase to assess its performance. We assess its performance using metrics such as MSE, R-squared, or accuracy, depending on the model. We then test the model on unseen data to ensure its generalization capability and reliability. Our final task focuses on interpreting the results and strategizing based on our findings. This starts with visualizing the results of our predictive model effectively. We map the predicted growth areas using GIS heat maps to show spatial patterns clearly. We also show the importance of each feature in predicting growth, highlighting key drivers. The last major step is to develop concrete recommendations based on our model's insights. We identify high potential regions that are ideal for future business expansion. We conduct what-if scenarios to analyze the potential impact of a new store opening. Ultimately, these insights guide strategic decisions, such as launching targeted marketing campaigns. To summarize, let us review the key takeaways from our discussion on business forecasting with GIS. These are the essential points to remember for effective business forecasting using GIS. Predictive analytics effectively uses historical and spatial data to forecast future business trends. GIS significantly enhances forecasting by providing precise location-based insights and visualization tools. Spatial big data, characterized by volume, variety, velocity, veracity, and value, powers advanced analytics. Machine learning, including supervised, unsupervised, and reinforcement methods, uncovers hidden patterns in geographic data. AI and GIS combine to deliver highly accurate market demand prediction, optimizing crucial business decisions. Time series analysis is vital for identifying trends, seasonality, and cycles in sales data for better planning. Developing predictive models involves careful data integration, EDA, robust model training, and strategic interpretation. Collectively, these technologies offer improved accuracy, strategic planning capabilities, and a significant competitive advantage.